Hi, we're Team 7, and this is our Predicting Customer Churn project. I'm Marissa Chow.
I'm Alex.
I'm Christina.
I'm Dana.
The problem definition for this project was to identify customers that are most likely to churn. And by doing this, we were given a data set of customer information from a telecom company. Our team built a predictive model to identify customers who are likely to churn. This will help you, the company, determine which customers to direct retention efforts towards. The overview of this project first we'll talk about the problem, second, important predictors, then going on and explaining our model, insights and recommendations, and how our model is limited and the future steps to take. We needed to select our attributes. By doing this, we first took the attributes from the data set and put it in the SPSS and test the statistical significance. We were looking for a p-value less than 0.05 and a strength of correlation strong enough. Along, we used visualizations from Excel to see the relationship between the variables. We also ran a collinearity diagnostic to ensure that we weren't using highly correlated variables. And by doing this, at the end of the model, we saw a few predictors that were at the utmost importance. The following 6 were the most important predictors determined by our model because they had greater determinants of whether a given customer was likely to churn. These predictors have higher weights than the others. For example, change in min was the percent change in minutes of use, equipped days, number of days they had their equipment, such as their phone. Ret calls is the number of calls to retention team. Drop means people in the top 10% of drop/blocked calls. Revenue quintiles is binned mean monthly minutes. And recharge which means they were in the 90th percentile of mean monthly recurring charges.
To determine which model would best fit the company's needs, we compared ROC curves for several models: logistic regression, decision tree, random forest, and naive Bayes, along with the naive model of simply choosing the mode. We chose to use the logistic regression model because this model had the ideal trade-off between specificity and sensitivity while still maintaining the largest area under the curve, as you can see with the yellow line. The decision tree model does have an even larger area under the curve, but we didn't like the trade-offs between specificity and sensitivity that model had. So now that we picked the model, here's some things that we did to make it work. We had to create a variable, the natural log of monthly minutes of use variable. We did this to normalize the skewed data and make it easier to work with, since the median was significantly less than the mean for this set of data. We didn't feel the need to create other variables due to the existence of the 90th percentile and single column dummy-coded variables that were already in the data set. We also had to deal with some missing values. Age 1, the age of the first household member, was the only variable we used that had missing values. It had 629, which was a significant amount. That 629 was 1.6% of the entire calibration sample, which meant we had to figure out a good way to deal with these missing values. We initially planned to exclude the age 2 variable from our model because it didn't have a statistical significance with the outcome of DV churn depth. However, we ended up using it because age 2 correlated strongly with age 1, as you can see in the chart. So we ended up including age 2 in our imputation process for the missing values of age 1, which we utilized the K nearest neighbors, which helps us replace missing variables with their closest match, depending on the similarity to nearest neighbors in the dataset. In this instance, we used K equals 5, so it would compare against the 5 nearest neighbors. We also ended up excluding age 2 from the model after doing this in order to prevent this from influencing our model. So another thing that we had to do was binning. We actually had to bin some of the continuous variables to help us manage it better and decrease the effective outliers within this. Because the logistic regression model assumes that there aren't any outliers, we ended up binning these to make sure that the outliers didn't affect the outcomes. We used the discretize by entropy function to bin these variables because it separates the data by lowering the entropy level for each interval, which essentially means that it splits data into bins that provide more information to the model instead of splitting the data randomly or by size. So setting up the actual logistic model. We chose to train the model on 70% of the calibration data and testing it on the remaining 30% because that would maximize the amount of information the model used to learn about the data instead of the traditional 50-50 approach. We chose to skip missing values because we already knew from before that the only variable with missing values was age 1. And we also chose to remove collinear columns just in case there were collinearity issues that we missed. For this model, as you can see, the accuracy was 60.32%, and this is from the performance operator that we put in that tested on the remaining 30% of the data. And the sensitivity was 59.76% and specificity was 60.93%, which basically tells you how good it is at distinguishing between type 1 and type 2 errors.
Now on to the results of our model. In this data set, 19,415 of the 39,000 customers are in our target group of churners. This data is split into 10 groups of approximately similar sizes. The range of values on the x-axis tells us how confident we are in predicting each group of churners, which decreases as we move towards the right side of the chart. As the lift curve, designated by the black line, reaches 100%, we can see how our model outperforms the model performing simple random guessing with 50% accuracy. By the fifth bin, we correctly predict 11,822 out of 19,500 churners, which is 60.63% of the churners. For the variable change M, which is the percentage of change in the monthly minutes of use for a customer, we see a lot of more customers churning at the second bin, where they range from negative 50% to 50% in change. We hypothesize that people who aren't using their plans much tend to leave the company. For the number of days with current equipment variable, we see a higher amount of churn for customers who are right around the 1-year mark. And in addition, those who are past that 1-year mark. This could be due to customers being unhappy with their phones or mobile plan around the time that their contract has expired, causing them to leave. Excluding 2 center quartiles here, we see that those in the lower 2 revenue quartiles tend to churn more than those in the highest 2 revenue quartiles. This means that those customers which less revenue is made from are likely to churn more. This may be due to them being unhappy with their service, possibly due to being on a cheaper plan with less features or no benefits. This could be worth looking into. This variable is an indicator of how many drop calls a customer has per month. Most users are under 25, but for those who are over 25, this becomes an important indicator of churn. So some insights and recommendations. We think that investigating those who don't have fluctuation in minutes of use will be worth looking into to see if they're still using the service. A recommendation would also be to provide equipment checkups to customers who have not upgraded their phone in a year or more, just to make sure they are still happy with their equipment around that time that the contract would be up. In addition, we would like you to start monitoring quality of service plans for those in the lower revenue quartiles, or quintiles, sorry, and to pay closer attention to people who are reaching 25 drop calls per month.
Limitations and future steps. So for limitations, we had the trade-off between specificity and sensitivity. We didn't account for outliers, accounting for missing data, and with our logistic regression model, in order for it to be useful, we had to already identify what all the important independent variables are. However, when we started out, there were a lot of variables of similar correlation coefficient values. So we cut out a lot of those variables and kept the ones that we subjectively deemed as important. This could lead to overfitting because the model could be just testing against itself. And also with logistic regression models, outcomes are discrete, so we can only predict categorical data. So future steps. The next step the company can initiate is to take the results the model generated and create a marketing plan that will put more effort towards these individuals who are more likely to churn. For example, they can provide incentives to retain the customer. Incentives can range from discounts on the phone bill if you use a certain amount of minutes to provide additional add-ons if they recommend someone to the service. Another step the company should implement is customer research. Why are these customers more likely to churn? Gather the data and use the results to make sure future or current customers do not feel this way in the future. Take precaution and adjust things that may be a factor in someone churning. Of course, in the future, the telecommunication company will have to build a better model with more up-to-date data on their customers. They would need to account for different external factors such as advancement technology and economic factors in certain areas. Learning outcomes. Overall, thank you, Baker, for giving us the opportunity to work on something that is so relevant to the workforce. Two big things we learned from doing this project is 1, to construct a predictive model in RapidMiner and diagnose errors and to be able to respond to them. And also have the ability to assess the source of a problem and using different operators to find the solution. Compare the advantages and disadvantages between using different models. And we were also able to interpret various charts and graphs, such as the ROC graph and the lift chart. Thank you very much.